I have I have opened a window, new window, and where I will be writing the report and putting the schematic, and I call this file name, whatever it is one, I call this file name, and in my I call the LTspice. This is the file I have. Okay, here I'm going to import some of them and see how it is. Now we talked before about drawing the schematic, and now one of the analysis we're going to have a lot of analysis we can do, and we're going to do that. We're going to simulate. We talked about it. Let us go to the simulate. There are a couple of them. First one is the operating point. It's the DC operating point. It's the transfer function between the DC input and the DC output. You vary the input. You want to see what is the input, what is the output, transfer relationship. You vary the input, you're going to see the output there. And you want to see the noise, we will not do it here. But DC sweep means that you sweep a particular, like a DC voltage from 0 to 10, you want to see the output. And then the AC analysis, basically the frequency, you vary the input with the voltage, with a certain voltage, with a different frequency, you want to see the output. And you want to see the transient, you want to see the transient time variant, and your input is a sinusoidal voltage or step voltage or ramp voltage, whatever the form, you want to see how they will respond to that. The first one you're going to look into that, you're going to operating point. You're going to see the operating point, like you see the way you're going to see operating point. And then let us save this one. We got to save this one. We want to see that operating point. That means the operating point like a DC, the DC BS is like a DC, and the R1 and R2 inductor will be like a short circuit for a DC, and the capacitor will be open circuit. Basically, you're going to see R1 and R2 is a potential elevator. That means if there is a 10 volts, let us put this at 10 volts is the DC sweep is a 10 volts DC sweep. And then we want to see the DC 10 volts. If you get a DC volts, you're going to see the 2 divided by 1002. It will be like almost like a 10 volts or 9.8 volts. You're going to see output. With this one, let's make sure to save it. We got to save it again. Now we want to run the simulation. Run the simulation. We could do that symbol, or we can run it here, and I got the output. Now once you got output, now the question is, then can I save it this one? I could click it to this one, copy and paste, put it in my report. I could take this one, put it in the report. I could have this paste. Can I paste it? Copy them. Let me see whether I can copy them. What is the LTspice? I could probably do copy them, or copy. And then go to my report. I should be able to paste it. It doesn't allow me to paste it. Paste option. Doesn't allow me to paste it. Let me see that what else I can do. Where my one is gone. Let me go to this window. That doesn't give me to this paste it. Then what else I can do? Would it I should be able to paste that one. Let's see, will the window put it this one to capture, not this one. You should be able to do it. How do I do that? You should be able to how do I run? How do I copy them? They should be able to do this, copy them, close. I should be able to copy. It doesn't give me to copy that. It should be helped to about the schematic. I should be able to run the schematic. Cometic is easier. I should be able to go to copy to the clipboard. Go to the copy to the clipboard. I should go there and then paste that, copy to the clipboard. That was easy. Then I should be able to go back and do that one. Why would not be able to do? I don't know. Run the schematic and it does not move. I should be able to print screen. I should be able to print screen. Print screen. I should be able to print screen. I should be able to copy. Select that, copy. I went to some of the schematic. Somehow I copied that one. I think I got this, my capture, schematic capture has that. Look into that, you should be able to find a way out to copy that. You know, I got some, I got a window, I got a picture, a square, I could move it around. That's what I have done. Okay, this is the one you have. Okay, let's go. Let's go back to the schematic. We want to go to the schematic. I don't know why I have two of them. There should be one. There should be one. I got another version. I got another version of the schematic. This is done. I got the two version. Like this is the version 2, and I don't need the version 1 is done. Was for the previously one. Then close that one. I got the version 2. Now one of the thing is done. I want to do the other one. I want to do this transient response. What I want to do a transient response. Put a setup, and I got a transient response. I want to put a before I do that, I want to change this to supply this one advanced to a pulse. I want to put a pulse voltage, say started with the initial voltage of 0, then on is like say 10 volts or 10 volts, and then the delay time is 0, and then rise time in say 1 nanosecond. Ideally, you should have some rise time. Theoretically, it's 0, but you can never have a 0. And then the fall time is 1 nanosecond, or you can say is that the on time is say point or 500 microsecond. It's like half the period. Period is 1 millisecond. Or you can say this is one of microsecond, same thing. A number of cycles, we don't see that. And now we want to have a pulse voltage of 0 to 10 volts, and then has this pulse of a rise time is nanosecond, a fall time is 1 nanosecond, is a pulse time is about 50% duty cycles. That is around the period is like 1 millisecond. We want to run that one. We have that one. I want to do this one, bring it here. This is the pulse I have. Once I have a pulse, that means that input is like this Vs is a pulse of this voltage. Now what I want to do, I want to run the simulation for say 2 cycles. I want to run the simulation for similar 2 cycles, like a transient analysis. Run for stop sign is a 2 millisecond, and then save the data from started from a 0. And then that's what I want to do. I want to see a run from 0 to 2 milliseconds. I want to get 2 cycles, full cycles, and then see the analysis of that. This is what I want to do. Now I have that, this is the one. I want to see that transient analysis of this one. I can put it somewhere, wherever you like. What I did, I think I lost this one. Let's go to do it again. This simulate. We got like simulate. I go to the setup. I want to do the transient. It's the one. I put it here. Okay, this is the transient analysis. Now in this LTspice, you put all the command in this platform. This is the. Now you can see that op is not anymore active. Transient is more active there. Now let me make sure to save it. Once you have saved that, now we run the simulation and we'll look to the input and output voltage. The output input voltage we expect a pulse. The output voltage we would see the response of them. Let us see what we get out there. Let us see what we expect. Run the simulation. We have the simulation. There was some pulse unknown to 0. I think there is an error there. You see that there is a typo there. This is a 0. It doesn't recognize that one. This should be pulse, should be 0, not O. That was the mistake I did typing it. It is 0, not O. That's what I have. Okay. Now with this one, it should run in now. Let me make sure to save it. For some reason, my computer goes something wrong. Then I got this. Run it. Okay. I want to see the output. I want to see the output across that the terminal 3. If I go there, click that on that this black the plot area, then add a trace. You can see that. You can see the trace V3. I want to see. I want to see the V3. You can plot the V3, and I got now it's like a sine wave. That means that it is like it's not. It's like a sinusoidal wave. It is like two sinusoidal, and it's just like oscillation going on. Now, if I increase the resistance or decrease the resistance, it will reduce the damping. Say if I make a 5, probably it will make a change. Let us see that. If I change the resistance to overdamp, it's down there. It's not 2, still not there. Maybe say 20. Let's say run it there. If I run it 20, let us see what happens. You see that? I can see there is some still an oscillation there. Okay. Now if I plot that one, you can see that there's an oscillation going on, and that it goes up and comes down there. The peak, there is a peak there. Now if I plot that on the same one, you can put a cursor. You can see what is your peak goes there. You can see the peak. You can go to the peak. How much is the peak happen there? And then you can put the window back here. You can look through that. I could on the same one. I could plot also that I could also plot here also the input, which is the terminal V1, and I could see the input output. I can see the square wave. Output is a pulse. This is what I have. Okay. Now the question is that how can I put it into my can I put these tools? What are the tools there? I could copy to the clipboard, and I could put keep it to the clipboard. I should be able to here. I put some grid. I could put some grid there. You can notice that I could put some grid there, and I could have also I could have this window. I don't know whether you can see that. Once I move this cursor, I also have that time and the voltage, and I could look through that. And there are other also functions you can do on this plot. You can put another trace, another plot. You can put the grade. You can color. And you can arrange the axes of this. You can manually limit those, the axes too. You have a lot of options to the plot settings. Then you got the simulation. You got the tools. You got this copy to the clipboard. If I go to the copy to the clipboard, this is what I am in. I should be able to go to my here, and I should be able to see. Let me go to this I got my plot. On that plot, I got here, there too. And you can see that I have now the plot. Now, going back to this one, I should be able to copy that one. If I come to here, no, it doesn't go. What about I copied the schematic at the beginning. Remember that? When I would draw the schematic, I draw the schematic there. Now, it is now let me say it doesn't give the schematic. If I bring it here, if I click that one here, and if I click it here, if I go back to this copy to the clipboard, what does it do? Does it give me that schematic of that one? Let me see that. Give me the schematic. Okay, you can give me a schematic. If you go to the clipboard, go to this picture, you can have the clipboard. Now I have the report, I have the transient response, And you could go back whatever you want to be do with this schematic. You can have also here you got input and output. Here you can multiply them, you can divide them, whatever you want them. Now you have those one. And then what else you can do? This is the one you can here. You can find out the V by I, and you want to see the power or the across that the V3. You can have a derivative of that. You can have you have this one transient response we have done there. Let us look through the other one. We want to look through this. We want to look through this schematic. Let's save it. We want to go to the another analysis we want to do. We got to simulate. Go back to the one. You want to do this AC analysis. What is the AC analysis? Means that you want to see the vary the frequency in number of octave per decade, say 1 and you want to start at say 1 hertz, 1 hertz, hertz. Excuse me. You want to go for say 100 kilohertz and see. And if you don't like the schematic, if you don't like the plot, you have to adjust that. Now I have another one. I got now this is the active. Let me save this one. I have this active plot here, not op, not the transient. I want to plot that the frequency response. Frequency response vary from 1 hertz to 100 kilohertz, and then it will be one octave. Octave, that means the 1, 10, then 10, 100, 100, and it will go by 10. Let us plot that one and see the simulate. I want to simulate, run the simulation, and then there is something there was happening there. 1 volts, make it a signal as AC analysis. Okay, value of a set of voltage is 1 volt. Like I did not set up the voltage here. I have to set that voltage here. I have to set that voltage like this here. I have to set that voltage here like AC voltage, like 10 volts or 1 volts or 10 volts. You put this 1 volts, maybe put a 1 volts, and then here I said that no phase single is 0. That is one that was missing that I had before, the 10 volts. This is one I put a 1 volts to see what the output is like. That's the one it was showing that you did not put this set up this 1 volts here. Now we got a 1 volts here. It should be saved. Sometimes you forget about it. You go do it, run it again. You change them. Nothing is going to wrong now. Now it should do like this. Look at that frequency. Now I have this Bode plot. This is called the Bode plot. The first one we have to make a sense out of that. The one is the hard one. Is that one? Is that this is the one is going into that the magnitude, and this is the one is the phase angle. The Bode plot is the magnitude as phase angle. Like this, the bandwidth depends on that. This is the one was 0. 70%, 70.7% of that is there somewhere there. Somewhere here, about 10 kilohertz will be the bandwidth, something like that. About 7 kilohertz, 7 bandwidth will be 10 kilohertz. Okay, that's what you have. Now here you got same thing you can have. You can find out that 70% of that you can read them. The actual voltage you can read them and see what voltage you have. Again, you can, if I want to, I could here I could go back and copy to the clipboard. I could view, I could setting, I could edit, plot, I could plot, I could grid connection I have, I could undo, you can arrange them, you can set plot settings, save plot settings, you can do that, you can view them, you can vary the area, you can have a tool, you can have this, vary this one, you can have the tail is copied to the clipboard, and you can also write plot to a file. You can have this. I go for the clipboard. Once you got a clipboard, now let me go back to my report on this one, and I should be able to see that. No, I didn't do that. Let me go back to my plot. Go back to this plot and go to the copy to clipboard. Once you go to the clipboard, it should work out. I have my plot. Now you can see that I have the plot I have. Now here I got now I have this one. Now I have now transient response. I got a frequency response. I want to see the other thing is missing. I want to plot that for this circuit. If I change the input, sweep the input, I want to see the output. That's what I want to do. Let's go back to this, the one. I want to show this DC sweep. I want to vary the DC sweep. The first DC sweep, VS. I want to go from, start from 0 to 10 stop volts, 10 volts, and then increment of say 0.001. It depends on how many steps you want. The more you have steps, the more accurate will be there. Now with this one, I have set it up. Now in this case, look at that active is DC sweep. My DC voltage will be sweeping between 0 to 10 volts. And then, let me save it. I got to save it. Now, once I have saved it, now I'll run the simulation. I'll go back and run the simulation. Look at that. This is what I have now. This is an input and output. The gain of the circuit, you can see this is an input and output. The gain of the circuit is like, if you get a 0.6, almost get a 6, because look at, there's a potential divider, and that is potential divider, and that is most of them is output there. You can find out. Now if you change those values here, the R1, say maybe 200, the gain will be the less. Okay. Now this is the one you can have that, you can have a DC transfer sweep, and if you again you can have that on this sweep, you can find out, you want to find out the current and power. You can, by the way, you can find out the current through the voltage, and also you can multiply the power of that resistance through 2. You can find out I of R2. You can make a product of the voltage and the resistance will be the power across the resistance R2. You can find out. Let us plot that one. You see that? You can find out that the power through the resistance, you can find out that. This gives me the power. It's possible to have a function of them. Like again, you want to copy to this, go back to the select which one you want, copy to the clipboard, and you can put it to your report. What you got, you got a report there. This is what I have. Okay. Now what else we need? We have this simulation. The other things we didn't do. We want to see this. We call that the other one is missing. Is called that. You call this setup. It's called the DC transfer function. What is the DC transfer function? If we have taken a circuit class, is a Thevenin's equivalent voltage. Thevenin's equivalent. If you look through a terminal, whatever the terminal you want, and then your output, and with respect to the input, you want to see the equivalent voltage and the resistance. Say we want to the output is across the V out is equal to V is the 3, and what is your input? Is a VS is your input. If your VS your input, the VS B3 the output, you want to see the Thevenin's equivalent circuit. That means that if you're looking into that V3 across the 3, you're going to see that a resistance and a voltage source. That's what you're looking for. Now, if I go through this one, look at that. The good thing, or whatever you want, or whether you like or not, the LTspice, they put all the command into your platform on the drawing board. Like you see, all the commands you have, they put it on the browser. But if you're looking for the other simulator, and it doesn't show it there, they are like hidden. You don't see them. You select them, they are not hidden. Like here, you can select them. Let me save it in case. Like here, I want to run this one. What I expect, I want a say number, like output voltage across 3 and equivalent resistance. Let us see what we got. Simulate. This is what I got. You can see now transfer function is almost 0.98 because the most of them input output relation is like if you got a transfer function relationship is like a gain. It's like this. The transfer function between the input output is like a 0.98, and then the transfer function and the input resistance is 120, and the output resistance is about 19 about 0.6 output. That is the Thevenin's equivalent. If you're looking from there, this, if you're looking from Thevenin's, that it should be, if you're looking from across the terminal 3, it should be 2 in parallel with 1K. 20 ohms in parallel with 1K. This will be between that one. This is what you got. Now in this particular case, I didn't know how to copy that. Let us see whether I can copy that, how I should be able to copy that. This one is there. I should be able to put it in the copy clipboard. Doesn't give me to copy in the clipboard. It doesn't give me the copy clipboard, and I cannot get out of the window. Now how do I do that? I don't know. I normally have a snipping tool. I just copy them. Okay, let me do this one. How do I do that? I will do this copy to this print screen, and then print screen. Let me give you that one. I don't know, it's a print screen. This will give me copy, and then copy, and then I go to the one. This is what I have. I got the output down. Now you can see that with this one I have showed you all this the features, most of the features of an LTspice. You can do that. Now you can have all the schematics you like to. One of the things I want to mention to you, like go back to this the trend analysis. We have that one. We got a trend analysis. We have. Let us run the trend analysis just to make sure that let me go to the trend analysis. Run this transient. This is the one I want to run the trend analysis. Okay, run the trend analysis. We want to see that again. Let me draw that output voltage across the V3, whatever the V3 I have. No, I have to go for the I didn't set it up trend analysis. I have to go for a pulse. Okay, I have to select the pulse, and I have to select the pulse. I have to make sure I select the pulse, like 1 volt, 0, and then you got this on 10 volts, and then we can have, or 1 volts maybe, and then we want to see this delay time in 1 picosecond, 1 nanosecond, and then fall time 1 nanosecond, and then the delay time, rise time, sorry, delay time is 0. There is no 0 there. The delay time is 0. Delay time, sorry, on voltage is 1 volts. Delay time is 0. This is not initially 0. This is 0. Then you got a 0, 1 nanosecond, 1 nanosecond. Then you got 2 on. It's like a point or 500 microsecond. Then period is like 1 millisecond. Then we got, this is a 500 microsecond, and then this is what we got. Now let me save it so that I don't forget that one. This will save it. Run this simulation. We mentioned too, right? Now I want to show one thing. This is the good features for that. I want to make this R is a dummy variable. Okay, I'm call this is a, take a look at that. The symbol I give a second bracket, this R val is like a variable. Now this is not anymore a, this is not a fixed value. This is a variable. Okay, if this is a variable, I want to give this now a command here. I want to give this spice command, that I want to give a spice command, and then this is the one I go for setup. I go for value here. I go for all value, and then I give a tolerance value, and then I give this. It should give me I command. I want to go back to this. I got so many windows I have. Okay. I want to go to that one. I want to go to that drawing board. I want to go back to this drawing board. Let me save it. I want to back to this saving book. I go now the saving board. I want to see this resistance. I want to put this command. I want to get this, the window. I want to go for the command. I want to give this, not this one. I want to give this. Do you want to save it? Yes. Let me go back. I don't know what I did. LTspice. I want to go back to this too, and this is what I have. I was looking for that command. What I do, look at this. I want to give a spot directive. I want to put this very important dot set param dot set param rval. I say dot set parameter rval list. I want to list it like 20, 200, maybe 100, 500. I don't remember the command exactly. Set, I say set the parameter list 20, 100 and 50 ohm. And that's what I'm saying. Say, okay, this parameter is a variable now. This is a very useful command for you, just to let you know that I hope this is going to work. I'm going to check that. I say the set the parameter rval list, the list command, or you could, increment. I got not a 500. I want to give this 100, 20, 100, not a 500, 20, 1000, 100, 20, 100, 500, and save it. And then let me run the simulation and see what you expect. It's going to run the simulation with 20, 100, and 500. I could see the effect of that variation of that one. Okay. Okay, rval, I go rval, okay. I'm not sure. Let me go for help desk. Go to help. Parametric. Okay, this is the one dot param. Okay, this is the one dot param. The dot param, I should have this dot parameter. This is the command. I should have put this one dot param. Let me write it down. I think sometimes you don't remember that. I don't know. I think I'll look for that. I'm not sure about it. I'll let you know about how to do this dot param. It should work. And param. Maybe I should put that param dot param dot param. Let me say dot param as rval set. Let me see how does it work or not. A set list set list set rval set list dot param set this. Let me see whether it worked or not. I'm not sure. Otherwise, I have to look through it again. I don't want to spend time. Simulate. Okay, I think that's end of the. I'll let you know how to do that. I forgot about it. I should be able to find out. I think set. I think this is the set dot set PARAM parameter r val the list 20 100 500. I think I'm not going to waste time now. I'll just do it. If it doesn't do it, I'll just leave it there. rval okay, rval list. Okay, I think that's the end of that. If it doesn't work, I'll leave it here. List 20. That's the end of it. Okay. Now, okay, thank you. I think that's the end of it. I will let you know what is the mistake I made. Thank you.